So I think the idea for this stream is probably pretty terrible. But let me explain it, and then I guess I'll see if I think it's terrible or not. So I think I'm referencing the I think it's called the progressive, or maybe it's style again. I don't know. So anyway, like the way a lot of generative adversarial neural nets work, like the generative part, particularly in the context of like image generation, they have this architecture where they start basically with, say, like a stack of maybe like 4x4 images, right? And so they have like a stack of these. Okay, I'm not going to draw the entire stack. But anyway, like, okay, like you start out from, let's just say a 2x2, right? And then, and then they have like an upscale layer, or like I forget what it's called, transpose convolution or something. So then they go from like, so basically like every pixel is subdivided. So you now have like 4x4 pixels. Right, like your original pixel, right, like this guy is now split into two. And, and so then you just do this repeatedly until you hit your desired resolution. I don't think I want to. What would the next one be? It would have like 6. No, it'd have 7 lines. Anyway, so also we went off the screen. So anyway, yeah, like this. Okay, so this is like 2x2, then it goes 4x4, and then you go to 8x8, and so it kind of suggests like the interpretation of like because it's like how does the GAN work? Like, what is it doing? And it's kind of like it's upscaling, perhaps, except kind of differently. So I mean, like, upscaling is like an entire task. I guess that, like, yeah, I mean, I don't know how well like neural nets perform on it, but it is a task where you have like you just have images, and then you downscale them, and then you feed, and then your training set is literally just the downscaled image, low resolution, to the neural net, and then to the high resolution. And that's like your whole training set. And so it kind of seems like that's kind of an interpretation of like what a generative neural net is possibly doing, at least like a progressive neural net, like progressive in the sense that it's progressively increasing the resolution. And so we wanted to mimic that idea of progressively upscaling an image to see what it does. But we wanted to, like, I don't know, do it without necessarily, without even using a neural net, just looking at the general idea of, I start with like a very low resolution image, and then I think like in particular I use like a convolution style operation to to like do the upscale, and then like just like see what sorts of images it makes. So this may or may not be a good idea. So I think like specifically, so to like be a little more specific about like what's happening. So I think like if you start with, say like a 2x2 image, and and then you're gonna scale it to a 4x4 image, using like a sliding window type thing. So it's kind of like, how is that going to happen exactly? Because, it'd be like, okay, 1, 2, 3, 4, right? These are individual pixels, and then, the original pixels are over here. And so it's somehow you are like increasing the detail. I think like, the way they work in like the progressive GAN is, you have like, I think just like a 3x3 sliding window. So, I think, so like that's kind of, okay, so we first need to figure out how to just implement like the sliding window, like the convolution using the sliding windows. Okay, so okay, so let's say we have this guy, and so like we want to like add detail, right? Like upscale or like add detail using, so it's something like you're gonna have a function that like takes, I guess, like a 3x3 window starting over here, and like each pixel in the right image is associated with a fixation point for our sliding window. Yeah, so like this pixel, like this guy, is going to be associated with like this fixation point. So like it's, it goes off the screen obviously, but I think that makes sense. So like, so the code would be something like, you would do, for like, so it'd be something like, probably easier to type this. So it'd be like for, row, column over here. You just say like pixel RC, like the output pixel, is well, like you need to compute the sliding window. Well, yeah, but it's like it's the same fixation point, I guess, is the idea. Yeah, so you'd be computing this sum, but also it's like, yeah, so I think like if you're always using like a 3x3 sliding window, and if we also want to keep everything binary, which we kind of do, then we just need a like a 9-dimensional Boolean function that will, so for each possible like input sliding window, right, that's 9 bits, and then we just need to determine a single output bit. And so we'll just do that repeatedly, and that may or may not be interesting. Yeah, so let's just implement that and see what happens. So I'm going to implement it using HTML and JavaScript. Which is interesting because I don't really, it's like, I don't even know how to like import a JavaScript script in HTML. How do you do that? Source script. Do you say script? Yeah. Source. Is this it? App dot JS. I think you want to like defer. I'm not sure that works. All right, let's see if that works. So we'll. Oh yeah, and I need to put something in the app. Console log hello world. All right, so now we're running our script theoretically. Oh, it works. Wow. I'm a hacker genius. Okay, so what was I doing? Yeah. All right. So okay. So here's the thing. So okay. So it's like how many? So I think we want to go from. Yeah. I think we just so like the final resolution. Let's just say will be 128, right? So canvas, and then I think you can say width, maybe 128 pixels, height, right? So this would be like our final output. Will be 128 by 128. Okay, so then so that means like we're gonna have, like we're gonna start out at a 2x2 resolution, just powers of 2, 2, 4, 8, 16, 32, 64, 128. Wow, I can count in binary. Yeah, so that'll be, yeah, so that'll like, so we start out with a 2x2 image, and then we have like a random like upscaling function. I guess like if our sliding window is 3x3, like we need to start at 4x4 resolution. And then anyway, so like we'll animate upscaling through these resolutions. So, I need like an animation function. Well, okay. So first of all, I need to get the canvas, and I of course don't remember how to do this. So whoops. So I'm gonna have to look that up real quickly. Maybe. Yeah. Okay, so this is from like an old file. And okay, I don't think I need any of that. Okay, I just need this. Alright. Okay, so this is canvas. This is the drawing context. Cool. Yeah, so let's see if we have a canvas display on the screen. No. Oh, that needs to be over here, dog. Okay. So, we should have a canvas being displayed. And we don't. Oh, because this should be like that. There it is. So this is like our image. That's the final resolution. So it's kind of small. Okay, and then we need animation. I guess I'll just call this step. I don't think we're passing anything. But also I forgot the, like, once again, I need to remember the API for doing animation in JavaScript. So I gotta open up an old file and request animation frame. Is that the whole thing? Maybe. I should really just leave that open, but that's fine. So request animation frame step. Okay, so let's make the canvas become increasingly darker, perhaps. So, so the dark, or increasingly lighter, I don't know. So we will increase I each step, and I don't remember how to do this correctly. Do something like that, and then I'm gonna have to open my thingy again. Why is this not working? Oh, also we never call step. Okay. Gonna have to figure out how to set color in JavaScript. How do you set a color in JavaScript? Oh, I didn't use a $sign. You gotta use a $sign. Cool. Okay, so now, whoa, look at that. Yeah. If I is 255, reset it. Oh, that is cool. I mean, okay, so we got that working. Alright, so this is all working. So, what were we originally gonna do? Yeah. Oh, also, you know, I'm not really sure like an animation is gonna work here. I mean, that's fine. We'll keep it. It's just going to look stupid. Okay, so what do I need to do? Okay, so I need like the, I think I need like the image data. Yeah, and I guess we're just doing this all in JavaScript, so Yeah, so we're going to initialize the image data. I think it's like for each resolution. Yeah, so the initial image is 4x4. Which, like, we're initializing this way. Okay, so that should be like a 4x4 array, perhaps. Object array is not a function. Isn't it though, if you think about it? I is not defined, yeah. Okay, so here's our image. This is our low resolution image, 4x4. And we're going to immediately map, so we're going to create a new image. Yep. We're going to create a new image using a sliding window. So the new image, so I need like current resolution. Current res is 4. That's the starting resolution. Current res. Alright. So we have like a current resolution. And yeah, and so we're gonna double that resolution at every step. I think I'm definitely going to need to implement like, I mean, whatever you call it, frames per second. So okay, so current res is times 2. I don't know if you can do that. And also, you know, we don't want it to be more than, I think 128 is greater than canvas width. Actually, if it's less than or equal to the canvas width, then animate. Otherwise, do not animate. So, like, stop animating. Okay, so this is our new image. And yeah, so it's a new image. And then we just have to set every pixel in this image based on based on the sliding window from the old image and a random Boolean function that we haven't defined yet. And then it's just going to create like a very cool animation that's basically going to blow everybody's minds. You know. What am I doing? Current I + = 1. And, oh, that didn't work. You're supposed to go inside. I mean, what's going on there? Oh, that needs to be an R, by the way. Great. Okay, so this is going to be new pixel value. I guess these are all just like binary or something. I don't know exactly how we're doing this yet. Okay, so this is going to be sliding window, right? Like compute the new pixel based on a sliding window. I mean, for now, let's just do like a threshold. So this is the sliding window, and we have to use different variables. We'll just do this. That's cool. Now the sliding window is size 3. That's hard coded. There's no change in that. It's hard coded. And okay, so we're going to say new pixel plus equals the old image. I should probably just call this old image. Because, you know, like we're kind of alternating images, if you can believe it. So this is the new image that we're working on. So the new pixel is the old image. Literally just, oh yeah, but, well, okay, you have to do bounds checking, which nobody likes. So if RR is out of bounds, which is, let's see, if it's greater than old image length -1. Well, I guess it's like you have to check both, because like both could happen, and then you have to check them individually. There's probably a better way of expressing that. Now I can't go out of bounds on the right or on the left, so that's cool. Okay, so like if both things are out of bound, well, no, it doesn't matter. It's just if any one of them is out of bounds, then we just say, well, I guess we just don't do anything. So we just, so we kind of want like the not of this. Okay, so we need, it's less than, if you're in bounds, we need both of them to be in bounds. Yeah. Then we do something. In particular, we add the value to new pixel. And then I think for now we're just doing like a threshold function. So then we're just going to say the new image, new pixel, and the new image is if the new pixel is greater than 2, then it's 1, else it's 0. Okay, so that should, oh yeah, and then we need to say old image equals new image. And then also we need to draw it. And then we're good. And like that's the whole thing. Except making this function different or something. Because yeah, I mean, like I think we want to use like an arbitrary 9-dimensional Boolean function. So it's like you're gonna have to collect this into a string, and then I guess just like do a lookup. Like we'll just, yeah, have like a hash map with all 2 power 9, which is 512, binary strings, and each one of those will map to a 1 or a 0. This is going to be very cool. This is going to create visuals that will melt your visual cortex. Everybody's visual cortex is going to get melted. I forgot what I was doing though. What am I doing? Oh, I have to draw. I have to draw the new image. Of course. Of course. I guess I could draw it simultaneously as I compute it. Yeah, I mean, why not? Why wouldn't you? Am I wrong? Am I wrong? So yeah, so just draw it right here. Just bring in this stuff. And Is there a reason that you couldn't? No, I don't think there's a reason. No, yeah. You can draw it simultaneously. So... let I equal 255. So it's going to be white or black. New image. RC. And fill rectangle starting at RC. And 1 pixel. Oh, yeah, this is the thing with the resolution. Yeah, because if it's a smaller resolution, you have to fill a larger, yeah. So, it's gonna be, I think it's just gonna be times the, 128, or like canvas width, divided by the current resolution, I think. So, so let pixel size be that, divided by the current resolution, and then just multiply everything by pix. Okay, so that should just straight up work. What's happening? Oh no. What's happening? I don't know, it's like it's lagging. I don't know. Okay, we'll just kill this and run it again or something. Alright, well, it definitely did something. That might actually work. That might actually be what it's supposed to do. 255. Although, I mean, it should be wider. Oh, well, no, it shouldn't be, actually. Yeah, you do need to reset it. Because, do you? No, I don't think you need to reset it, actually. Okay, that needs to be C times pixel. Alright, everything's black. Yeah, we do want to randomly initialize the old image, actually. And also, I mean, the animation is way too fast. Which, yeah, I mean... So, yeah, I mean, we want the animation to be like 1 frame a second. So, we're gonna have to figure out that again. Okay. So you have to say last frame, date now, and then just do this. Actually, do both of that. All right. So, and get rid of running. And so we're saying we want the frames to be like a second, which is 1,000 milliseconds. Can you believe that a second is 1,000 milliseconds? How's that possible? Okay, now I forgot if this needs to be inside of the frame. Yeah, I think it needs to be outside, because otherwise it doesn't get called. Alright, let's see what we got. Perfect, look at that. Boom, 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 boom. Okay, now the reason it's all black is because we're, why did this not stop? It was supposed to stop? If current resolution is less than... Oh, because this is always... Yeah, that's fine. Okay, wow, so that's just gonna count your powers of 2. Is it? Those don't look right, but whatever. Okay, so we need to initialize the initial image. So let's do that. And this looks like garbage, but that's cool. So we want it to be math, I think random, greater 0.5, question mark, 1, or 0. Okay, so that might do something. So what does our initial array look like? Okay, that looks fine. Why is that? Yeah, no, that didn't do it. Well, why is it? Okay, obviously that didn't do correctly. Oh, because, no. Yeah, because it needs to be within map. That may or may not help. Oh no. And then that needs to be explicitly a function. Okay, that looks better. Yeah, okay. So let's make the threshold smaller. Like, if it's... Oh, greater than 2. Greater than or equal to 2, make it a 1. Okay. Well, I mean, at least it's working, like, yeah. Alright, okay, then, okay, so I don't think the threshold function works, so the last thing we will do is create the actual Boolean function, which means, let's see, which means, okay, so I'm just going to implement it as a giant array. Very cool. Look up function, and it's taking 2 power 9, so it just has to be 512. 512 map, or like, yeah, you have to do fill 0 first, I think. Maybe you don't have to do that anymore. I don't know. And then, yeah, just map. And then, okay, so that's the lookup function that will update the pixels. Why is that giving me an error? Okay. So that's lookup function. Okay, so then we're going to figure out the index into the lookup function, which b plus equals 1, 2. How do you do a power in JavaScript? Is that it? Yeah. 2p, and then you say the new pixel is now equal to lookup function new pixel. And yeah, hopefully that does something cool. Nope. Nope. Hey, sometimes it oscillates. That's pretty cool, right? So it seems to get a lot of zeros. Huh. What's your name, little girl? Log the lookup function. Huh. Also, let's for each like display the old image. So for each row element log the row, I think. So now what's happening? What the fuck is happening? Okay, let's just do the first 120. Let's just say 64 and figure out what's happening. What is it doing? Oh, yeah, we want this to be over here. Get rid of that. What is it doing? What is 32? What is it printing? Like, what is it printing? I have no idea what it's printing. whatever. Okay, so anyway, this is the starting image. And then it immediately goes to 0. I wish I could figure out what is this coming from? A 32 array. Where is there a 32 array? Like, so it's like everything zeroes out like immediately, which makes me think that there's a bug. Oh, it's printing this for 64. Okay, never mind. But anyway, okay, so why are we zeroing out immediately? That's the question. Oh, well, well, okay, maybe this needs to go outside. Yeah, you're incrementing that no matter what. Ah! Why is it zeroing out immediately? Like... Because if you make the lookup function constantly 0, or constantly 1... Oh, okay, well, in that case, okay, that works. So... make it like 30%? Okay, then that goes... Okay, so let's make it like 40%. Why does it go constant? Okay, it's going constant. Like it either goes constantly 0 or 1. So I'm thinking this was a terrible idea. Okay, yeah, I'm just gonna say that was a terrible idea. But thanks for watching all the same. Yeah.